In this video, we'll learn about capacitor. What is it? And some of its behavior, like why does it allow only the AC signal? And some interesting facts like what is the difference between capacitor and battery? The evolution of capacitor started with Leiden's experiment. So in his experiment, when he passed a static charge through this wire and the hanging rod coming to water inside the jar and asked his lab assistant to touch one of his hand to bottom of the jar and another hand to the hanging rod. So when his assistant did that, he received a huge shock and told, "I'm never going to try it again." So with this experiment, Leiden told that this setup stores huge charge on it. Let's see its definition now. It is a two-terminal passive device made of two electrodes. In this case, it is metal plate kept at some distance, filled with either vacuum or some dielectric. And when it is connected to a voltage source, the plate which is connected to the positive terminal of battery accumulates the positive charge on it, and the other plate which is connected to the negative terminal of the battery accumulates the negative charge on it. So in this way, this capacitor stores the electric charge on its plates and produces an electric field inside it. So this ability of capacitor to store charge on its plate is known as capacitance, and this capacitance can be calculated with this formula: charge stored on its plates per volt. And for a parallel plate capacitor, this capacitance depends on the area of the plates. The bigger the area of metal plate will provide more capacitance, and the distance between two plates will reduce the capacitance of capacitor. So if the two plates are kept at more distance, it will provide lesser capacitance. And this capacitance also depends on the dielectric material used between two metal plates. Its SI unit is farad, but this is a bigger value, so very often this is used in either microfarad, picofarad or nanofarad. And if you see this electrolytic capacitor carefully, its rating is 450 volt and capacitance is 22 microfarad. Means this capacitor will work till 450 volt of supply, and if we increase the supply voltage more than this capacitor may damage. So applying more voltage can damage it. Energy stored in the capacitor can be calculated with this formula: stored energy equals to half CV squared, where C is the capacitance and V is the potential difference between the metal plates. Let's see some of its interesting facts now. So in this circuit, this capacitor is connected with resistor with a switch, and if the switch is closed for this supply voltage, this capacitor will start accumulating the charge on it. And the time this switch is connected to second place for the short circuit, the charged capacitor will release the charge from it and it will be dissipated across this resistor. So it looks like it is similar to the battery, but there is some difference between capacitor and battery. Let's see that. First thing, the way energy is stored in the capacitor and the battery are different. On one side, the capacitor stores the electrical energy in its electric field, while on another side, the battery stores electrical energy in the form of chemical energy. The second difference, a capacitor is a passive device, means it doesn't generate or enhance the electrical energy, while a battery is an active component and it can generate the electrical energy. One thing to notice here, for the ceramic capacitor, it's written here 103. So what does it mean? So the number present here, either 3 or 4, is a multiplier. Means the 4 zeros will be added up here, and this is in picofarad. So it will be 10 to the power 4 picofarad equals to 100 nanofarad. The another difference, the capacitor charging as well as the discharging time is very less, while on another side, batteries charging and discharging time is in hours. The time capacitor is connected to the voltage supply, it starts accumulating the charges on its plates. So that time initially it behaves like a short circuit, and when this capacitor is fully charged, it will block the flow of the charge and works like a open circuit in full charge condition. Since this capacitor discharges very fast, or we can say it releases the energy immediately, it is used for the flashing purpose in the camera. Let's see now some of the capacitor connections. If capacitor is connected in series, then it can be calculated with this formula, and the total capacitance will decrease. And if these capacitors are connected in parallel, the total capacitance will be added up. Now let's see how the capacitor able to block the DC. When it is connected to a supply voltage, it will accumulate the charges on its plates, and the time it is fully charged, it will block the charge flow and works like an open circuit. So this is the reason the capacitor blocks the DC signal, or we can say it blocks low frequency signals, and it allows AC, because in AC signal the amplitude of voltage as well as the polarity changes with the time. So in the positive time frame, capacitor will charge, and for the negative polarity, it will release the charge from its plates, or we can say it discharges in this time frame. So this is how the capacitor allows the AC signal. So now we can say capacitor only allows the AC signal. With this behavior of capacitor, it is used as coupling capacitor and able to couple two circuits. It will allow only the AC signal from circuit 1 to circuit 2, and it works to decouple the noise from the circuit as well. Since an IC requires an stable input voltage, so to do that it requires noise free input. So on a PCB there are many noise, so it must has to be filtered first. So to do that, decoupling capacitors are used, and these capacitors are placed very close to the IC. These decoupling capacitor gives the stable voltage to IC. This tantalum capacitor of having higher capacitance of 10 microfarad takes more time for charging as well as for discharging, so it suppresses all low frequency noises. And the other ceramic capacitor of having capacitance 0.1 microfarad takes very less time for charge as well as for discharge. It removes or suppresses the high frequency noises.